All right. Good morning, everybody. Let's go ahead. Let's get started with the lesson today, and that was and we'll try to cover as much as we can. So I want to try to finish up with the discussion of naming and writing the formulas for the ionic compounds, and then get into how these ionic covalent compounds, and then get into how these covalent compounds form. Okay, but I'm sorry, let me go ahead. Let me start my timer here really quickly and stay on track here so I don't lose the track of time. All right. What I'd like us to do though, to start out with, and I want you to go ahead and take a couple minutes, maybe a couple minutes. I don't think it should take you any longer than that. But go ahead and grab your chapter 9 problem set. And I would like you to go ahead and let's do number one. Number one from the chapter 9 problem set. The reason why I want us to do this is because, like I told you, I think it was on Monday, when you go about doing, you have to be able to identify the difference between ionic compounds and molecular compounds. So physically, in terms of their physical properties, I've already mentioned that. You did a PhET lab to kind of get you to see them. Some differences that we can observe between molecular compounds and ionic compounds. But you also have to be able to recognize the differences in the way that we name them and in the way that we write out their formulas. Okay, so let's go ahead and let's use this opportunity to go ahead and practice that. So what I'd like to do to start out with here this morning is I want you to go ahead and grab the chapter 9 problem set, and let's do number one. And number one, they give you four different compounds. They give you the formulas for those compounds, and they want you to tell whether these compounds will have covalent bonds or not. And it's molecular compounds that have covalent bonds. And so that's how that's why I was saying that this problem give us a chance then to identify the difference between ionic and molecular compounds, because ionic compounds have ionic bonds holding the atoms together, and molecular compounds have covalent bonds holding those atoms together. So let's take about 1 minute and let's work on number one from the chapter 9 problem set. Okay, go ahead and get started. Okay, hopefully it didn't take you too long to do that. Hopefully it was fairly quick. Hopefully you remembered what to look for. Let me go ahead and open up a whiteboard here, my whiteboard here, and let's go ahead and let's take a look at this. And let's see how, let me go and do this here. Let's see how then we will go about identifying the difference between ionic bonds and covalent bonds. That is, how to identify the difference between covalent compounds and ionic compounds. Okay, so let's go ahead and let's take a look at the first one, and let me go ahead and open up my get my pen here. All right, so the first one is KCl, and so again, let me go ahead and let's do this here. Pen. Okay, so this is number one, chapter 9 problem set. So let's go ahead and let's get this one done. Okay, so the first one they give us is this formula here. Okay, now hopefully you recognize then that this formula is going to be an ionic compound. So I'm going to go ahead and write this in. So this is an ionic compound. Okay, that means then that the two atoms in this binary compound, the two atoms here, are held together by an ionic bond. And how do we know that? Okay. Well, from the formula, we should recognize this, that here we have a metal and here we have a non-metal. So whenever you have a metal and a non-metal together, okay, then you know then you have the ionic bond. That is how we know. And so they ask us why, okay, we should be able to answer that as well. Okay, so ionic compound, metal, and a non-metal. And that'll always be the case. Why? Because the metal then becomes your cation, that's the positive charge. Your non-metal then becomes the anion, that's the negative charge. The reason why the cation, potassium here, becomes positively charged is because it gives an electron over to chlorine, and then chlorine now becomes an anion that we refer to as the chloride anion. Okay? So hopefully you're able, I just maybe as a quick exercise and more practice, be able to name this compound as well. Okay? All right, let's take a look at the next compound. Here we have PBr3. Okay? All right, this is going to be a molecular compound. Okay, this is going to be our molecular compound, which means then, and maybe I should write this in, so that you're going to have an ionic bond. This is an ionic bond here that holds those atoms together. This is going to be a covalent bond, and we're going to talk much more about that today, that holds these four atoms together. And again, and so let's go ahead and see how it is that we know that this is a, molecular compound by looking at the elements that actually come together to make this compound. Both of these are non-metal atoms. Phosphorus is a non-metal atom, and bromine is a non-metal atom. Okay, and so two non-metals together. Okay, that means that we have no charge. There's not charge. The bond that interacts and holding them together then is the covalent bond. Okay, so what are you going to look for? You're going to look for two nonmetals being interacting with each other, and that's how you can confirm then that this is a molecular compound that's being held together by a covalent bond. Okay? All right, we'll come back to naming this in just a moment because we had a chance to practice that already. Okay, but we'll come back and we'll name PBr3 in just a moment. Okay? All right, let's take a look at the next one. Okay, we have ClBr. That's the formula there. Hopefully you recognize it again, that this is a molecular compound as well. Okay. That is the chlorine and the bromine atoms are held together by a covalent bond. Okay. And again, how do we know this? Look at the atoms that make up this compound. Chlorine is a nonmetal, bromine is a nonmetal. We have two nonmetals again. So we have two nonmetals that are attached to one another, that are bonded to one another. And so therefore then we have another molecular compound. Okay. All right. Looking at the last one, and again, maybe we'll go back and we'll name all of them. Okay. Looking at the last one, we have then NaI. Okay, so let's go ahead and do this really quickly. Hopefully you see then that this is an ionic compound and how it is that we recognize that this is an ionic compound. So this is an ionic compound as well, meaning that the two atoms are held together by an ionic bond. Okay. And how do we know that? Metal and a nonmetal. We have the sodium ion, the sodium atom and the iodine atom. Okay. One is a metal, the sodium is the metal, and the iodine is the nonmetal. Okay. And that's how we know then that this compound is an ionic compound. Okay. All right. Now, if you notice here also, for both of these, for all four of these, I'm sorry, not both of these, for all four of these, we have now, we have binary compounds. These are all binary compounds as well. Okay, so we have one element, two elements. We have one element, two different elements that make up each one of these compounds here. So all of these are examples of binary compounds. Now, you would look at this and you say, well, wait a second. PBr3, there are four atoms that make up this particular compound. How is it a binary compound? Okay. It's binary because remember, binary means in two different elements, not two different atoms. All the other ones do have two atoms in, as well as two elements. But the term binary, remember, refers to two different elements. So we have in each case then, this is a binary compound. This is a binary ionic compound. This is a binary compound, but this is a binary molecular compound. So binary compounds just simply means, the term binary just simply means then that there are two elements that make up that particular compound. Okay, and they can you can have binary molecular compounds, binary ionic compounds as well. Okay. All right. Last thing I would like to do then is let's go ahead and I didn't ask you to do this, but let's go ahead and do this together. Okay. And I'll work. We'll write this down. Hopefully you can write this down as I'm working it out for you. Let's name the first one here. Okay. Ionic compound. Name the cation. Name the anion. Cation then is potassium. Anion then is, remember, this is the chlorine atom, but then we drop the last three letters and add IDE, so this becomes potassium chloride. No Roman numeral here because potassium is a representative metal. We don't need the stock system. It's not one of those four exceptions either. Okay. All right, let's name this molecular compound here. Now with molecular compounds, remember, we're going to write down the names of the elements in the order that they are listed. Okay, so phosphorus comes first, so we're going to write that down. So phosphorus is the first element. Okay. Bromine is the second element here. Okay. But remember, with the second element in a covalent compound, what we need to do then is we need to drop the last three, drop a certain number of letters. Okay, so in this case then, just like with the ionic compounds, we're going to drop the last three letters for bromine, and we're going to add in the suffix IDE. And so if you notice then, that is what both the ionic compounds and the molecular compounds have in common in terms of their name. If they are binary, they're going to end in IDE, and we see that here in both cases as well. But again, these are two very different compounds. Potassium chloride is an ionic compound, and this compound here, PBr3, which we'll finish naming right now, is not an ionic compound. It's a covalent compound. Okay. All right. So with that said, then what we have to do is we have to add the prefixes now. We have to remember those prefixes to indicate the number of each one of these atoms as well. So phosphorus here, there's only one. So based on that, we should include the prefix mono. Okay, so one phosphorus mono, and then three. The prefix for three would be tri. Okay. All right. So right now we have it as mono phosphorus tribromide. But the very last thing you want to make sure you remember then is the first element in the sequence. If there's only one of those atoms, we do not need to include the prefix mono, so we can get rid of that. So the name of this compound, a molecular compound, then is phosphorus tribromide. Okay. All right, let's take a look at the third compound here. This is a molecular compound. So again, we're just going to list the atoms in order that they are given. So chlorine comes first. Again, we have bromine, and so I'm going to go ahead and change that to bromide. Okay, so we have chlorine, bromide. We have one chlorine, but chlorine comes first, so we do not need to include the prefix mono. And we have one bromide, and so we have to include the prefix mono there. So this is going to be chlorine monobromide. Okay. All right, very good. So folks, please make sure then that you memorize those prefixes. Okay, you got to memorize those prefixes, and once you have that done, naming the molecular compounds, very straightforward, very easy. Okay. All right, last one then. It's going to be sodium iodide. Okay. And I want to point out to you one last time then, and just to make sure that you see this. Okay. In each case here, they all end in IDE. Regardless of whether they are ionic or molecular, since these are binary compounds, they all end in IDE. And that may hopefully help you as well. Okay. All right, let me go ahead and save this here. And if you have any questions, please stick around after I take roll tomorrow and ask me about this. Okay? But let me go ahead then, and I'm going to open up and let me go ahead and do this here. Let's finish talking about the sorry about that. Let me stop sharing that. Okay, let me go ahead then, and let's sorry. Okay, let me go ahead. Switch this up real quickly. Okay. Sorry, move this around really quickly, guys. Put that in there. Okay, and one last thing. Okay, let me go ahead. So let's go ahead then. Well, let's finish up talking about, we just reviewed how to name. We learned about that yesterday. Let's go ahead then. Let's pick up where we left off yesterday. And that is, if you were given the name of a molecular compound, you should also be able to write the formula. Okay? And the process is equally easy. Okay, so let's go ahead and let's review how we do that. Okay, so first of all, you have to be able to identify that you have a molecular compound, and that's why I wanted to do number one from the problem set, get started with the day with that. And so with the formula, when you write out the formula, it's pretty simple. It's pretty simple to identify or to see the difference between an ionic compound and a molecular compound. Why is it simple? You look for the metal atom. If there is a metal atom, you know it has to be an ionic compound. But there's that one exception with ammonium, but just keep that in mind. If you don't have a metal atom, or if there's no metal atom present in either the formula or the name now, you know then that it has to be a molecular compound. So looking at this particular compound here, which is what we started with yesterday, looking at the name, there's no metal in that. How do we know? The names. You have silicon, and then you have oxide. Okay? Oxide obviously is derived from oxygen. Hopefully you recognize that as well. So neither silicon nor oxygen are metal atoms. So you don't have any metal atoms in this name. There's no name of a metal present in this particular name here. So there's no metal. This cannot be an ionic compound. You know it has to be a molecular compound, and that's what you're going to look for. Okay? That's what you're going to look for. And so once you have that identified, folks, everything else is pretty straightforward. I think the hardest part of doing, and when I say hard, I don't mean it's going to be that difficult for you. You're going to recognize it pretty pretty quickly. Okay? But if there is no metal present in the name, if there's no metal present in the formula for the compound, you know it has to be molecular. Okay? All right, so with that said, let's go ahead and let's quickly use this to kind of review what we did yesterday. So now that we have established that this is a molecular compound, okay, we go ahead then and we identify what the first atom is. The first atom then is going to be the silicon atom. Okay, so we will. And again, even though I have all these questions listed here, these questions listed here for you, like I pointed out to you yesterday, at some point, hopefully, all of these questions are you don't have to consciously think about them. You are unconsciously thinking about it as you go through and you write out the formula for this compound. Okay, all right. Prefix. Okay, there's no prefix. Okay, and so therefore, remember for the very first atom, there's no prefix that indicates that there's one of that particular atom. Okay. Second atom we have then is oxide. Okay. Okay. And the prefix that we have there is going to be di, which means then we have two of them. Okay. All right. So with that said, then what's the formula? Well, we just need to go back and identify the symbol for each one of these atoms here. So silicon is going to be Si, and oxygen is just going to be O. Okay. All right. So with that said, then we're going to write down both of those. It indicate the numbers. We'll use these numbers here as a subscript. If there's one, remember we don't need to write that in. If there's two, we just write that in as it is. So that is going to be our silicon dioxide. That's how we got that. Okay. All right. Let me go ahead then, and that's what we did yesterday. Let's go ahead then and let's take a look at the next one. Okay. Whoops. Sorry. Okay. Let's take a look in at this one here. Arsenic pentachloride, and let me go ahead and let's yeah, word. Okay. Is it a molecular compound? Yes. We don't have a metal or no metal atoms in here at all. So this is a molecular compound. Okay. What is the first atom? Arsenic. Okay. And I'm just going to go straight to the symbol now. Okay. So arsenic is going to be then AR. Okay. I'm sorry, AS. Sorry, that's argon. Arsenic is AS. Sorry about that. Okay, so this will be AS. Okay, any prefixes? No prefixes. So therefore, there's only going to be one atom. Okay, that represents one atom right there. So go and write that in. Okay, second atom then is chloride, which means its symbol is going to be Cl. Okay, prefix then is penta, which means then that's going to be 5 of those atoms. Okay, and so when we write out the formula, then we're just going to write down the symbol. Okay, for each one of those, we have arsenic is As, chlorine is Cl, and then followed out with the subscripts here: 1 for arsenic, 5 for chlorine. There is arsenic pentachloride, folks. Like I said, writing out the formulas then is going to be an easier task than writing out the names. And the name was already pretty straightforward. Okay, let's do another one. Okay. Iodine tribromide. Let's go ahead and let's take a look at this one really quickly. Okay, and is this a molecular compound? Sure. There's no metal in this. Iodine is not a metal. Bromide is not a metal. So we can go ahead then and we can say then with, we can continue on. We say then that this is a molecular compound. So we're going to go ahead and we're going to indicate the name, the symbol for the first one. First atom is iodine, which is going to be the symbol with I. Again, no prefix, which means that we only have one atom. Okay. Second atom is going to be bromine, okay, because hopefully you recognize bromide. If you drop the IDE here and kind of go in reverse, this element then is going to be bromine. The prefix then is going to be tri, which indicates then that we have 3 of those atoms. Writing out the symbols, symbols for each one of those elements, and then also including the number as a subscript, we get then the formula for iodine tribromide. Okay. So that's it. I know that this is very straightforward. It's simple. I hope then that you don't have to spend too much time on this, because what you want to do is you want to make sure that you invest your time in what we'll be doing next. Okay. And so what I'd like you to do then is take about a minute here, or hopefully it takes you only about a minute to get this done. Take about a minute to go ahead and write out the formulas for these 3 molecular compounds here. So first of all, hopefully you recognize that they are molecular compounds. Okay? And so go ahead and write out the names. Take about 1 minute to get that done. and then we'll go over it. Okay, so hopefully it'll be pretty straightforward. Go ahead and give it a try, and then yeah, again, if you need to look at those questions again, the questions that I had in the previous slides to help you through this, go ahead and do so for now. But hopefully you're getting to the point where you can work through this in a pretty straightforward way, that you are unconsciously thinking about those questions and writing out your answers. Okay. All right. So take about 1 minute. Let's get this done, and then we'll go over it together. Okay. All right. Let's go ahead and let's take a look at this, folks. Okay. First of all, hopefully y'all, everyone recognizes that all three of these here are molecular compounds. There are no metals in either one of these. Dinitrogen tetroxide, carbon tetrabromide, diphosphorus trioxide. There are no metals in that. They have to be a molecular compound. Okay? And so with that said, then the answer to whether they're molecular compounds or not is yes. Okay? All right, so let's take a look at the first one. Go ahead and identify the atom for the in the first one here. The first atom is going to be nitrogen, so we're going to write down the letter N. Second atom then is going to be oxygen, so we're going to write down the letter O. Okay, so nitrogen and oxygen are the two elements that make up this compound. The prefix for nitrogen is di, which means then that represents 2. We're going to write that down as a subscript. Tetra is going to remember, this is when their two vowels are together, we drop the A in tetra. So this is the prefix tetra, which indicates that there should be 4 of those in there as well. So N2O4 is dinitrogen tetroxide. And as you noticed, I went through all the questions. So we did answer all 8 of those questions, but we did it in a fairly quick succession. Okay. All right, let's take a look at the second one. Carbon is the first element. They give us that. Let's write down the symbol for carbon. Bromide is going to be bromine, so we'll write down the symbol for bromine, which is Pr. No prefix for carbon, which means that there is 1 carbon atom, so we don't have to write a subscript there. There it is. There's tetra again, so the prefix for bromide is tetra, so that means then we have 4 of those. So we have then CBr4 as carbon tetrabromide. Okay. All right, let's take a look at the last one. We have phosphorus is the first element, okay, and oxide is the second element. So phosphorus and oxygen, okay. The prefix for phosphorus is di, which means that we will have 2 of those, okay. And then tri is the prefix for oxide, so we'll have 3 of those. So that's going to be then our diphosphorus trioxide, okay. All right. Very good. Let me ask you to go ahead and do this then. So let's go, just a little bit more practice here before we wrap up here. And I would like you to take a look at, let's take a look at number 8. Okay, let's do number 8 from your from the chapter 9 problem set. So we're still on chapter 9. Let's take a look at number 8 from the chapter 9 problem set. Again, take about 1 minute to get this done, and then we'll go over together. Just a little bit more practice with writing out the names and for these compounds here. Okay. All right, go ahead and get that done. Number 8 from your chapter 9 problem set. Okay. All right. Let me go ahead then. Let me go ahead and save this here, and I'll post it for you. Okay. Let's go ahead then. Let me open up my whiteboard here, and let's take a look at number 8. So number 8 here, it's just a little bit of practice in writing out the names of these compounds, okay, of these molecular compounds. Okay, let's go ahead and let's quickly go through this. This is going to be number 8. Excuse me. Excuse me. Number 8 from the chapter 9 problem set. Okay. All right. So here they give us the formulas. Okay, and so let's go ahead and let's take a look at these here. So for the very first one, hopefully you recognize this is a molecular compound. No metals here, or if you want to think about it, 2 non-metals. We're going to go ahead and write out the name of the first one. Just follow the sequence. Okay. Binary compounds. The name of the second one is going to be oxide. Drop the last 4 letters of oxygen and add an IDE. 1 nitrogen, so we don't have to include any prefix here. 1 oxygen, so we're going to include the prefix mono, but drop the O at the end of mono in order to accommodate the 2 vowels that are together. So this is nitrogen monoxide. Okay. Hopefully you got that. SiO2. Okay, silicon is the first element, so we'll write that down. Again, we have oxide as the second one here. 1 silicon, don't need to include the prefix mono. 2 oxygens, And so we'll include the prefix di. And if you notice here, yes, we got two vowels there together, but in this case, then we don't drop the I. Okay, so make sure you keep that in mind. So this is silicon dioxide. Okay. All right, let's go ahead and let's take a look at the next one. N2O4. So we have nitrogen as the first element, oxide again as the second element, two nitrogens here, so that'll be dinitrogen, and then we have four oxygen, which is going to be tetra. But we drop the A in that case. Again, why is it we drop the A with tetroxide and the O in monoxide? We don't with the dioxide. Like I said, chemists, they fancy themselves grammarians, but we're not. Okay. All right, but we try, not grammarians, but we try to kid ourselves so we can make things sound better, but it doesn't work out too well. Okay. All right, so with that said, then let's take a look at the last one. The last one is Cl. It's not Ci, so it's not carbon, iodine, fluorine. It's chlorine and F3. So the very first element is chlorine. Okay, and the second one is going to be fluoride. Okay, one chlorine, no prefix, and three fluoride. So we have trifluoride there. Okay. All right. So hopefully, yeah, you got that. If not, please make sure then you stick around afterwards, after class tomorrow. I'm sorry, after I take roll tomorrow and get your questions answered, so that you don't have to worry about naming as we move forward with this. Okay? Now, the last section of chapter 9, I will cover after we get done with the chapter 8 material. Okay, so acids and bases. We'll talk about. We'll need to know those because with acids and bases, let me go ahead and make note of this really quickly. With acids and bases, we will learn about those in chapter 19. Hopefully, we'll get to that towards the end of the semester here. But we'll go over that, and that. But we will talk about the naming and the formulas for the acids because that's part of the naming chapter. But we'll do that after we don't get done with chapter 8. Okay, so let me go ahead and make note of this really quickly. And let's go ahead then. Let's talk about then. Let me switch gears here a little bit. Let's move back to chapter 8. And so now that we know how to name and we can identify the difference between molecular compounds and ionic compounds, what we want to be able to do then is we want to talk about, we know how ionic compounds form. So we know how ionic compounds form. What we want to be able to do now is we want to be able to talk about how molecular compounds form. We want to do the same thing. Let me go ahead and get out of this, and let me open up the new slide here. Let me go do this. So what we're going to do now is we're going to talk about then how these covalent bonds form, and we're going to be doing this for the next couple of lectures, and hopefully try to finish this up by Monday. Okay, but we need to know how covalent bonds form, and like I pointed out to you, the method by which we're going to approach this is very similar to how we approached writing out the ionic, remember with the ionization reactions, how ions form. We're going to do the same thing here. The reason why covalent bonds form is the exact same reason why ionic bonds form. The atoms want to be stable. And so we're going to talk about the octet rule, and I'll talk about that again in just a moment. And then we're going to continue on, and then we'll talk about how these different covalent bonds form. So if you notice here on the first slide here, you're going to see then that we have single covalent bonds, double covalent bonds, triple covalent bonds, and then we're going to finish out this section by talking about those bond energies. Why the energetics of why these the strengths of these bonds, these covalent bonds. You're going to see then that covalent bonds actually are fairly strong. They are fairly strong, even though covalent compounds, molecular compounds, have low melting points, low boiling points. They have they tend to be liquids and gases room temperature. Even though that's the case, the bond itself is a fairly strong bond, which we will talk about towards the end of this section here. Okay, so let's go ahead then. Let's talk about why then covalent bonds form. Well, covalent bonds form because the atoms that are involved in the covalent bonds can have a need to become stable and achieve a stable electron configuration. And we saw then that a stable electron configuration resembles that of a noble gas. Okay? And so with these atoms here that bond covalently, they also will strive for the noble gas configuration. And there will be exceptions, just like we saw exceptions with the pseudo-noble gas configurations with the metals. We're going to see some exceptions here as well, and we'll talk about those exceptions as we come along. But for the most part, the reason why covalent bonds form is because the atoms want to obtain the noble gas configuration. They want to become stable. Okay? They want to become stable, and we're going to see then that the nonmetals will do so by sharing their atoms. Okay, so we're going to be focusing in on the elements of groups 4, 4A, 5A, and 6A, and 7A as well. Okay, all right. So with that said, then there are three basic types of covalent bonds. That is, there are three different ways that atoms can share their electrons. Now remember, covalent bonds represents then a localized sharing. That means then, though I mentioned three different types of covalent bonds here, it's the two atoms sharing their electrons in three different ways. And why are there three different types? Well, we're going to get to that, okay? But make sure you keep in mind then that even though I talked about single bonds, double bonds, and triple bonds, and they are referred to as single covalent bonds, double covalent bonds, and triple covalent bonds. But I throw out the term covalent because that's just a little too much for me. So I refer to them as single bonds, double bonds, and triple bonds. Okay? But these are just ways that atoms can share their electrons so that they can achieve their octet. That's what you need to keep in mind. That the difference between the single bond, the double bond, triple bond is in the number of electrons that they share. But what result or why two atoms choose to form a single bond versus the double bond or triple bond simply depends on how many electrons each atom needs in order to achieve their octet. And it'll make much more sense when we go ahead and we do these reactions here. Okay, so the difference in the bonds then is just going to be it's going to depend on the number of electrons that are shared. Okay, and I'm just going to go ahead and indicate that now really quickly for us. Okay, and sorry, let me go ahead and do this. Whoops, what happened to my share button? I'm sorry, I haven't even told Tom I didn't share it with you. Sorry about that, you guys. All right, there it is. Okay, well, at this point then, like I said, the three types then are going to be based upon the number of electrons going to share. We'll be talking about that as we go through. Okay, but each type then, not only will there be a different number of electrons that are shared, but their bond strength, the bond energy is going to be different, and then this physical quantity that we call bond length. The bond length and bond strength, we cannot see those, we can measure them. Okay, but they also help us to differentiate between the three types of covalent bonds here. Okay, so we're going to talk about those. Okay, and let's start out then with the let's start out with the single bond here. Okay. All right, so the single bond then is what characterizes it is that the atoms share only two electrons. Okay, two electrons, so they share one pair. So what you want to make sure you understand then is that when we talk about the covalent bond, the single covalent bond, what's being shared then is just two electrons, okay, between the two atoms. And we're going to go ahead and we're going to highlight them. We're going to see how that works. Okay, so whenever you have two electrons, that is one pair, that is shared between two different atoms, you have what's called a single bond. Okay, and so the single bond then, like I said, is going to have a different bond energy. It's going to have a different length. Okay, but let's go ahead and let's take a look at an example of how a single bond forms between two atoms. Okay, and let me go ahead and clear this out really quickly. Okay, and let me go ahead and let's take a look at. Okay, whoops. Okay, let's take a look at hydrogen. I think the simplest atom to look at, and let's examine hydrogen first. Okay. So hydrogen then, each hydrogen, so we have a single hydrogen atom, and let's go ahead and take a look at this. Hydrogen, that's the Lewis dot structure for hydrogen. So folks, if you don't remember how to draw the Lewis dot structures, if you need to refresh on that, please come by and see me as well. Okay. So with that said, now, and I think I've already talked about, I want to use this to start out because I've already dealt with this before. Okay. So hydrogen then, that is the simplest atom, one electron in the 1s orbital. Okay. And so this hydrogen here we saw then could go one of two ways. It could form a cation by losing that electron. It could form an anion by gaining another one. Okay. But we saw then that makes it a little bit more unstable, okay, or it's not as stable a situation as possible, though hydrogen can lose one and can gain one electron. Okay. But what it would prefer to do is that it would, if it could find another hydrogen, okay, what it will do then is it will go in and it will share its electron with that hydrogen. Okay. This bond right here then, folks, is a single bond. That's a single covalent bond. Why do we refer to this as a single covalent bond? Or or what I will, and most chemists will refer to now as simply a single bond. Okay. Why is this a single bond? 2 electrons. So you have your 2 electrons that are shared between both of those hydrogen atoms. And once that happens, then the formula for this compound then is going to be H2. Hydrogen now has come together, and so that's 2 hydrogens that are coming together. And so the compound here is then going to be H2. Okay, and so we can name this as dihydrogen. We don't typically name it that way, but now what you're going to see then is that the formula that we would use for H2, I'm sorry, the electron configuration for this compound then is going to be 1s2. That's going to be hydrogen, which resembles in which noble gas? Helium. Okay. Okay. So with that said, then, what we're going to do tomorrow, and what you'll see in tomorrow's lesson is that we're going to continue talking about how these molecular compounds form. So elemental hydrogen. So hydrogen does not exist as a single atom. It does not exist as a single monatomic element. Okay? It is actually what we refer to as a diatomic element, and we'll go over a few more of these tomorrow in lesson. Okay. All right, very good, folks. What we'll do then is what I'd like to do is I'll post for you some more practice for you with the naming and writing out the formulas. So please make sure you get that done by tomorrow, and then we're going to pick up tomorrow in our lesson with writing out the formulas here and also showing how these bonds form, these single bonds, double bonds, and triple bonds. Okay. All right. Let me go ahead and let me save this really quickly for you, and then I'll post these notes for you as well. Okay, and I will see you folks tomorrow in class. Okay, all right. Have a good day, folks.